During this service that we offer, we test the house pre-drywall in terms of air leakage rate to see where we are at, and then we try to find leaks using a blow door, an infrared camera, or sometimes in summer smoke pencil. Since we are not able to use the infrared in summer, we need at least 10 degrees temperature difference between inside and outside so that we can see leaks. And basically, why are we doing this? And I'm not going to go into the details of it. I know that most of you are on board, but the reason, to me, and for passive house, and a lot of people ask, why reducing the leakage rate to that ridiculous level, is durability. Of course, energy efficiency is second, but first we are trying to make a house that basically doesn't have any moisture migration into the wall system. And keep in mind, in high performance houses, we have thick walls, and most of these walls are using cellulose, which is absorbs humidity and can basically, over years, it can lead to durability issues, accumulates humidity. And of course, if there is an HRV installed in the house, the value of that HRV will increase with a tighter envelope. What is the payback of an HRV installed in a very leaky house? 30 years? Air leakage is usually also associated with the poly. And there is some confusion in terms of the role of the poly. The poly is first and foremost there to prevent diffusion. That's a mechanism where humidity travels through materials. Whereas air leakage can cause heat loss, but through that air movement, convection, a lot more humidity can enter your wall system or roof system or building envelope. Now, I have, in terms of energy savings, this is these results of an energy model for a basically code-built house. We're looking at R22 nominal insulation in the wall, which would be something around R16 or 18 at the end, counting the thermal bridges, and R20 in the basement, and an air leakage rate of 4.5 air changes per hour at 50 pascals, which is an average. The first bar here shows the heat losses happening due to ventilation and air leakage. Second is the basement, doors, windows. These are minimum code windows. There's a little bit of an exposed floor in the house, and the main walls with the R22 nominal insulation in there, and the ceiling. And by the way, this is a two-story house, so the proportion of wall to ceiling is higher. So as you see, the largest heat loss is due to air leakage if we achieve 4.5. Some houses are around 8. It's double than that. So, but now as next, we're looking at the energy simulation results of the same house, but we're reducing the air leakage rate by 2 to 2.5, which is Energy Star level. And here we go. That bar is now not the biggest heat loss in the house, but is now the third after the walls and the windows. So just to let you know, in terms of quantity of, what in terms of energy savings air leakage can do. Now, what we do is we depressurize the house and look at the walls with an infrared camera. Here we have Roxol poly. It's a straightforward construction, and the poly is the air barrier as well. So we have two functions for the poly: preventing diffusion and also blocking air leakage. As you can see here, the poly is bulging. That shows that we are depressurizing the house. This is the top floor of the house, so there is no insulation on the ceiling, and therefore it's blue, it's cold. But as you can see, we are pulling air through the walls, and that's because the sealant here on the top plates had not been applied. This is the same situation after drywalling. So we are depressurizing, we're pulling cold air from the attic into the wall, which then usually is the other way. Basically, we are losing that heat to the attic. We are reversing the mechanism right now. Now, looking at other areas of houses, we see, this is to be expected. These are the shims of the window here at the bottom, and there are ways to accommodate that. There are U-shims, they're less prone to leakage, and there's a foam strip from Stiga. That's the best. I think Greening Homes use that. Stephen, what's the name of the product?
Well, the product we used was ExoAir Trio.
I see.
I don't think that was the Stiga part.
That was not, but it's the foam strip.
Yeah,
Trio is the Tremco product.
I see. Okay. Now, this is an interior wall. We are on the top floor. The poly is attached to the top plate of the interior wall, but we see that there is air leakage happening. I mean, this cavity will not be filled with insulation, and we see that this seam here is leaking, and it's been missed because the poly has not gone over the interior wall. It's just attached to the top plate here. This one is a very interesting one. Again, a conventional wall, but a foamed flat roof, a hot roof. As you can see, there is not much leakage happening here. There is a little bit of leakage around this here, but along this side of the house, it's leaking like a sieve. I mean, it hits you in the face. The reason is that the foam is not connecting to the poly. There's actually a gap that I could put my hand in between. It's just that the foamer didn't connect, that he has to connect his air barrier, which is the foam, to the poly here. So luckily we were able to get him back and address that. Here is the same thing happening. So we have poly here. The poly is taped, and then the window or the doors are foamed. However, they're not connected. And you can see we are pulling air along this French door here. Header, foaming the header. Foam seems to be, for a lot of people, the silver bullet. It's not. I always make the analogy of Lance Armstrong said he is a champion until he was really tested. So just to think that the foam will take care of your air leaks is a marketing thing from foam companies. The foaming there is a lot involved in the foaming. Who pulls the trigger? What are the temperatures? What is the formulation? Humidity levels inside. So we always will be able to find some leaks more or less. This is a corner, and corners are tricky because they're tight. So this header here looks all right. Here it looks all right too. There is a little bit of leakage there. You can't see it here, but there. But this corner here, because it's not accessible for the foaming gun, he's not able to air seal that corner. And also we have like a piece of wood here that is, even making it harder for him to get in there. So, or this one here, this is a nice one. Or Greg coined this, it's like a shadow. The foamer is foaming this way and casting a shadow just behind this framing member here. This is a top floor of a gutted house. It used to be a knee wall, but now it's included in the thermal envelope. So basically, behind this stud here, there's a huge leak that is caused by the angle of how the foamer was foaming without knowing that he's not getting behind that to seal this leak here. These ones are crevasses. This is this spot. It's not much different than these spots here, but they're not leaking. This one is leaking. It's like a crevasse in a glacier. If you dig down, you find suddenly a hole, an empty space, a cavity behind the foam there. So this is the stuff that, through testing, we can detect and address before drywall goes up and everything is too late. Now, foaming, that's an air barrier. That's what we're told. However, what's happened is that between framing members, there are sometimes gaps. The studs are never straight. So we can see here, there are leaks happening between the framing. So if we had gone the conventional way, put a poly on top, that poly would have taken care of all these leaks. Now we're just air sealing between the framing members. Now if you have 2, 3 framing members together, they will leak. I'm going to come back to this, but there is a way, and we have some recommendations on how to approach this, but basically I can go through, show you pictures of leakage along framing members, top plate, corner here, baseboard, and again, where wood touches wood, it will leak. Maybe not along the entire wall, but at some point, somewhere where the wood is a little bit crooked, it will leak. And another corner here. Corners are very prone. This is an interior wall. This is the exterior wall. So here's the framing members, and they leak. As you can see, the direction, this is like the plume. Or this one. This is a retrofit. You can see these are the old framing members. However, it was foamed in between the studs, but this was missed. And again, the person who triggers, is using the gun, he has absolutely no concept of air sealing. He is applying insulation between the studs. So, my recommendation is when you have foamers there and that's your primary air barrier, just make sure that you talk to this foamer and make him aware that, if there is a gap, you should fill it, or you fill it later. This one is also something that we encounter a lot. Windows, these are existing windows in a retrofit situation where parts of the house was retrofitted. Most existing windows are leaking on the top. You can go home, put your hand there, and you actually may encounter a gap on top of the window. It's never been sealed. For years it's been leaking like this. The reason is no one is looking at the top. If you look at the bottom, I don't have a picture there, but there is no leakage on the sides nor at the bottom. It's sealed. It's just the top that no one looks, and it's just left open. Ah, that's a nice one. Pot lights. So we are depressurizing. This is, again, an existing house. Pot lights will leak, regardless of what you're going to do. Just don't put them on the top floor. Or if you're putting them on the top floor, think about a suspended ceiling, because they will leak. This is actually, we made these IR pictures with a different camera, with our old camera. It's not as good as our new one. However, this is the same photo. So this is a boot put on top of the IC-rated pot light. So you can put insulation on top of it, but this is leaking. So by foaming over it, the idea was to prevent that leakage. And actually, the boot was sealed also around the perimeter. You can't see that here. But when we go and pressurize the house to check the ceiling, that's what we find. This is the boot. This is basically that foam glob. And that perimeter is leaking warm air. That's why I'm saying, regardless of what you do, and this was a lot of work. There were 65 of these in that house, and it's just not working. Now, just to review, the various approaches in terms of air barrier, we have the poly air vapor barrier. It's in one, applied on the inside, goes. This is the header wrap. It has to be sealed here, sealed there. Lots of penetrations. It's very difficult to air seal the vapor barrier. But there is also the approach with building paper. That's much easier because you just tape the outside. However, that building paper is prone to damage and piercing during construction. And basically, it's not my favorite. You can use sheeting that is either insulated but also acts as a as an air barrier. And this is it. I think Greg Manny, you use this, right? What was the air leakage rate measured in the house in your project? 0.6. 0.6. This is a fiberboard, Excel. The air barrier is applied on the outside, and just you need to tape the seams, duct tape, and 0.6 air changes per hour. It's passive house level. You never aimed for it, did you? You just ended up with it.
Nails.
And
You touch it. That's all it is.
but
Yeah.
but also nails, if they are under compression, they're not leaking.
You have to use a specific staple.
Yeah.
They recommend.
So
What is that made of?
fiberboard is recycled, so it's a substitution for your regular plywood or OSB. And basically what we're doing here, we're separating the air barrier from the vapor barrier. We're putting the air barrier on the outside, which there are less penetrations. When the air barrier is on the outside, you don't need to air seal the vapor barrier because there is no movement in the air in the wall. So in order to have air moving through the wall, we need two holes. So we need a breach in our, say, air vapor barrier, and since the sheeting is not air sealed, that's how air leakage happens. However, if the sheeting is the air barrier, for a leak to happen, again, you need to have a leak here and there so that the air can move to the outside. So by basically putting the air barrier on the outside, it's easier to air seal it, but you're also going to prevent the taping festival that's going on with the poly inside and frustrating everyone, and it will never work. I'm done. Any questions? So our recommendation is really separate the air barrier, put it on the outside, use something like the XL sheeting, which is a substitution for regular sheeting and is recycled. And never pot lights on the top floor. Thank you.